Okay, so we're looking at features of science. What is science and what makes something scientific, and is psychology a science? So the first thing we look at is paradigms. And a paradigm is a shared set of assumptions and methods. So this is what distinguishes science from other disciplines. Like, for example, in what we normally think of the sciences, biology, chemistry, physics, they have a shared set of assumptions and methods, like they use the same kind of experimental methods and so on. And that's what distinguishes them. The question is, does psychology fit into this? And progress takes place in science when someone questions the existing assumptions that are in place, and then gradually over time a new paradigm comes to be accepted. And this is as a result of maybe new experiments or new findings in science. So that's how progress takes place over time. And you'll look in more detail at this question probably in your issues and debates topic, but it's been questioned whether psychology really is a science. I know we use a lot of scientific method when we do experiments and so on, but you could argue that psychology certainly doesn't have a paradigm, because if you think about psychologists and all these different camps that they're in, an evolutionary psychologist would have a completely different approach to a social psychologist or a cognitive psychologist. And they all have completely different assumptions. If you think about it, someone working in the psychodynamic approach would be making certain assumptions about unconscious parts of our personality that were influencing our behaviour, whereas it would be completely different if you were working in the biological approach. So you could really question whether or not psychology is a science because of this kind of lack of a paradigm. Although some people do go on the side of psychology is a science because we use scientific method and we're looking at observable phenomena and so on. So I'm not going to go in detail into the debate just now, but as long as you understand that that's why that's questioned, or one of the reasons, because it doesn't have that kind of shared assumption in the same way as the other sciences. So theory construction then. This is how we come up with a theory in science. It's a set of general laws or principles that have the ability to explain particular events or behaviours. That's what a theory is. And we construct theories by gathering evidence through direct observations. So if, for example, you have a theory that smelly socks grow their own life form, what you would do is you would put your smelly socks in some kind of special container. You'd leave them for like 5 days and see has a fly suddenly emerged from these smelly socks. And if it has, then it proves it. You would construct a theory. So you have to gather evidence through a direct observation first of all. And then once you've got your theory, you would generate hypotheses from it. So if you've got a good theory, it should be possible to make clear predictions based on it, i.e. hypotheses that can be tested, and that's called deduction. So hypothesis testing is where these hypotheses are tested using scientific and objective methods to determine whether it would be supported or refuted. So for example, if someone had just come up, let's imagine we're way in the past, and the multi-store model of memory has just been put forward, we could generate a number of hypotheses from that, such as short-term memory has a limited capacity. We could test that. We could say that, for example, rehearsal is necessary to transfer things to long-term memory. We could test that. So you can generate hypotheses from a theory that's been put forward. If the hypothesis that you've tested stands up to scrutiny, then that strengthens your theory. If you test your hypothesis and find it's not true, your smelly socks haven't suddenly produced a fly, then it won't be it. You might need to go back to the theory and revise it. Okay, another feature of science is falsifiability. And the basic idea of this is that if you've got a scientific theory and it's a good solid scientific theory, it should be able to cope with hypothesis testing. You should do hypothesis testing because it should stand up to the idea of being proved false. If you hypothesis test it and it is proved false, then you've proved it wrong. But if it's a good theory, you should still try and prove it false, because that strengthens the theory. And even the theory of falsification says that even when you've repeatedly tested a theory successfully, that doesn't mean it's necessarily true. That's why we don't use words like "we've proved that" in psychology. We always say "this suggests that." I'm sure you've noticed. So the theory says it just hasn't been proved false yet, the theory of falsification. It doesn't mean that it's true yet. It just hasn't been proved false yet. And pseudosciences can't be falsified. So if you've got a sort of scientific thing that is not very scientific, it's not good science, you can't falsify it. This is one of the problems with the evolutionary theory in psychology, is that actually there's not really any way to go back to the EEA, the original environment, and test these theories to check if they're true or not. The evolutionary psychologists can come up with these theories, say this aspect of our behaviour relates to back then, but we can't ever actually challenge it particularly or falsify it. And that's a major weakness of it, because if we've got a good theory, we should be able to really bombard it with testing, check the hypotheses, check them again, check them in different ways, and find that they all stand up to scrutiny, and that would say this is a good theory. Okay, all of that stuff is called the hypothetico-deductive method. Hypothetic, kind of relating to our hypotheses, deductive, relating to kind of testing your hypotheses. Okay, then another feature we've got is replicability. It's something we've talked about in relation to reliability, because if you can replicate it, it shows that a study is reliable, or a theory is reliable and consistent. You get the same results each time, but it also shows that something is valid because it can be generalized to other contexts. If you test a hypothesis in more than one context and it stands, that shows that you can generalize it to this new context. So that shows that you've got external validity. So that's partly why replicability is so important, because it should be shown to be repeatable across a number of different situations. And that's why, as we talked about how science is reported, that's why it's really important to do that method section really well. We talked about that list of steps, making it really precise and really clear so that someone else can replicate it. Because we want to make sure that we can thoroughly and in a watertight way we can replicate it and test this theory. If you replicate it but don't replicate it properly and something else changes, that other thing could affect your DV, and then you could find actually you've completely missed the point. So it's really important that when you replicate, you're actually replicating accurately. Right, I think this is the last bit, objectivity. Scientific researchers must be objective. They can't allow their opinions to influence the research. We've talked about this in the context of investigator bias. That's really important, especially with psychology. Obviously, like biologists or chemists, their personal opinions about whether the experiment will work or not is it doesn't matter, because chemicals aren't going to be affected by their opinions. However, psychologists have found that rats, for example, are affected by personal opinions of the researcher. I know that sounds ridiculous, but humans are triply or massively more suggestive than rats, open to suggestion. So that means kind of if you communicate in some way that you believe the experiment's going to go in a particular way, they're much more likely to show demand characteristics and react to that. Those methods with the highest level of control are the most objective. We know that already, because you can remove investigator bias as far as possible in an experiment by having everything standardized, pre-recorded, and so on. You're very familiar with that from doing research. And then empirical method. Objectivity is kind of what underlies what we call the empirical method, which is where data is collected based on direct experience. That is obviously what we do in psychology in terms of experiments and observations are the key ones where that happens. But something you have to, if you want to have a scientific theory, it has to be empirically tested and verified. You have to directly collect data based on direct sensory experience. And until you've done that, you can't claim to be scientific, because you have to. Empirical, the word empirical means to do with evidence. You have to have direct evidence for your theory that you're putting forward. Okay, that's it.